Happy, what day is it? Uh, Tuesday? Happy day to everyone here. Um, I'm going to tell you a story. We're going to tell a couple of stories, actually. If you haven't gone there already, by the way, the link at the bottom of the slide shows where you can actually get these slides online and follow along if you so desire. So I'm going to tell some stories. Last year and much of this year for me has been a journey of discovery, dealing with JavaScript performance, in particular performance in Node, and dealing with trying to make things run fast, because when things run fast, ultimately you pay less money, or the client pays less money. Okay. So the format of this presentation is very much a sort of storytelling format, but that doesn't mean that it's going to follow any kind of rules of narration. This is just a series of stories, some stories within stories, and yeah, let's get going. So in January 2016, I don't know if anyone was listening to Matteo's webinar yesterday, but Matteo and I have been working quite closely together, especially in early 2016, where we basically had a mandate to translate a lot of the performance knowledge that particularly that Matteo had and translate that into training material, and also into working with clients. I think I should mention I work with Nearform. We're a consultancy company, so we go and help people write code in a way that's fast, or help with architecture, all that kind of stuff. So our mandate and our mission was to help people with performance problems, simplify the optimization process wherever we go. So here's a little bit of sensory detail, and don't worry, I'm not going to do this a lot, but basically it was a golden crisp morning in Italy. The smell of rich coffee lingered pleasantly in the air as I made my way along the marble porticos of Bologna's ancient palaces towards Matteo's apartment. In short, I was in Bologna with Matteo, and he started telling me a story about his recent work at that time with a company that you've probably heard of, News Corp, who one of the things they do is they publish the London Times and the Sunday Times. So Matteo told me this story about how he'd been working with them. There's a case study link there you can go and check out. But essentially, there was a lot of data that needed to be delivered within a very short frame of a very short moment in time because of legal reasons. So we had to get it delivered very, very quickly to I think it was tens of millions of devices. So Matteo said this, and I'm going to play a sound clip now of basically Matteo's quote. Here we go.
I got the code to a point where we couldn't optimize it anymore because it was going faster than the capacity of the network card. In fact, the network card became the bottleneck.
So the network card in this case became the bottleneck. It was an AWS machine which actually have emulated network cards, so they're capped at 720 megabits per second. But this was a great achievement, and we started trying to break down some of the things that had been done and kind of putting them into a format that was digestible. So I started looking through his code that he'd written for this project, and it was like there was an angel and a devil on my shoulder. On the one hand, there was the angel saying, yeah, well, this is great, but this code looks terrible. This is really poorly written code at first glance. It looks like, you know, a 14-year-old is just learning JavaScript here. On the other side, the devil was saying, you know, who cares? It's fast. That's what they want. That's what they need. They want performance. And really, they were both right. I didn't need a moral dilemma. I needed a moral solution or a moral of the story. And that moral is, when you're optimizing code, make sure that you comment why you've optimized it. But don't comment inside the function, comment outside the function, because comments can cause functions to de-optimize. Yeah, I'll just say it again. Comments can cause functions to de-optimize. This may not be true moving forward when we go to turbofan and ignition, which I'll talk about at the end. But essentially, the size of the function, basically V8 does a quick check on the size of the function, and if it's above, I think 512 bytes, including comments and white space, then it won't attempt to inline it. So a comment can actually push that character limit over that threshold, and then V8 will simply not try to inline that function. However, it is important to signal to yourself in the future and to other developers why you've written a function a certain way, so that they don't try to fix what is perceived to be poorly written code. Again, moving forward in the future, it looks like turbofan and ignition, which is the next iteration of V8, which has been enabled in Chrome and will be enabled in Node 8. They're kind of optimizing more for code that follows better practices, more declarative code. But as much as I was enjoying looking through Matteo's code and dealing with that dilemma, a sense of urgency had crept in. We had a lot to repair, and we had precious little time. The purpose of myself and Matteo getting together was to codify the performance knowledge into training material and consultancy planning for a client engagement the following week. And this engagement was with Net-a-Porter. Again, there's a link to a case study there. Net-a-Porter and Mr. Porter are a fashion brand in London. I believe they're purely an online retailer, but they have a substantial setup in London, and they wanted the kind of help that empowers their developers to make changes rather than relying on consultants. And that's the kind of help that we like to give. So we had 2 days of showing techniques and tools, and then we had 2 days applying techniques in groups to their respective code bases. Once our changes have been implemented based on the discoveries that we made, they ended up running on 1/3 of the servers with twice the throughput and half the latency. So essentially twice the performance for 1/3 the cost. So we came away from Net-a-Porter pretty inspired. There's a lot of things that this engagement threw up for us where we realized certain things were missing in the ecosystem. And we had our own little Cambrian explosion. Essentially, several tools and libraries were built as a result of the inspiration we got from this engagement. The big three are Pinot, which is the little tree on the left there, 0x, which is the flame in the middle, and autocannon, which is the whatever that is on the right. It represents a cannon, right? So let's talk about those, because these essentially are tools that you can use to discover your own bottlenecks and performance enhancements you can make. So the 0x story is essentially we had a moment during this engagement, actually, the night previous, where we figured out something that was impossible and made it possible. That's what Deus Ex Machina means. So if you've heard of flame graphs before, then but you've not heard of 0x, hopefully you'll be excited about this. If you've not heard of flame graphs, I'll just explain what a flame graph is really quickly. So this is essentially a diagram that represents the function calls and how long those functions were observed on the CPU. Essentially what happens is we take time slices, 1 millisecond time slices, like snapshots of the stack on the CPU. And this goes all the way from the C layer up into the JavaScript layer. Actually from the kernel layer up into the JavaScript layer. And then what we do is we aggregate that information into this flame graph. The length of a block on the flame graph, a block represents a single call site or a single function call. The length of a block determines essentially how long that function was on the CPU in a call stack. Not necessarily running, but part of a call stack. So that function may have called another function. So at the very bottom there, you see the red, long red stack, and it says node 0x5. That's actually the main.cc file with the main function in the main.cc file in C. So obviously, for the most part, apart from that little bootstrapping guy before it, that's going to be on the CPU for the duration. The color of each block represents how long that call frame or that function was observed at the top of the stack over multiple samples. So when it's seen at the top of a stack over multiple samples, that essentially indicates that the function is blocking the event loop in some way. It essentially indicates that the function has been taking a long time to execute the code within that function. And this is where we get the name flame graph, because you have these little peaks and troughs, but you also have a kind of a color scheme. So in this particular case, we can see in our own sort of code, or the code that we can control, there's an underscore run function in the restify module that's actually quite hot compared to the other stacks, and that would be an investigation point. So flame graphs aren't a new thing. They've been used in the Java community and the C community, particularly by DevOps. Brendan Gregg actually made them famous, I think. But what we did with 0x is we figured out how to get flame graphs to be generated on OS X, now Mac OS, in one step, and also made it so you could generate them on Linux in one step, whereas before it was about 6 or 7 steps to get them to work on Linux, and you just couldn't do it on OS X. Essentially, that was because dtrace, which is used on OS X to capture the stacks, had reduced capabilities because of subsequent Apple releases, basically disabling parts of dtrace for reasons. At the time, the highest version of Node, when we were working on this, was v.12. But that was enough, because it introduced the --perf basic prof flag. So the perf basic prof flag, it actually generates a bunch of hex addresses to function name, like a map file between hex addresses and function names, sticks them in the temp folder. With dtrace, we were able to capture the hex addresses, but not the names of the JavaScript functions. So we were able to, when we put this flag on, we wrote a little tool called Perf that actually takes the hex addresses and figures out what their JavaScript names are. And this was the first piece in actually getting to 0x. So once we got it working on OS X, after the engagement, I went away and built this tool. Basically, you just go npm.im/0x, npm install -g 0x, and you've got the tool. So what you do is you just, instead of running node index.js or node app.js or whatever, you run 0x app.js, and it'll do the dtrace, enable the flag, do all the different things to capture the stacks. And when you close your process, say you hit Control C, it will end up generating an HTML file, which is the flame graph, and you can even interact with it and see, where you start diagnosing the problem. So that's 0x. Check that out. Autocannon is Italian for machine gun. So it's essentially, it's an HTTP benchmarking tool. We were using Apache Bench and WRK, if you've heard of those. Apache Bench is typically, if you ever did PHP, you probably heard of Apache Bench. And WRK is used on Node Core for actually benchmarking Node Core. Autocannon, both Apache Bench and WRK are written in C, but Autocannon's written in JavaScript. However, Autocannon can saturate an HTTP server 10% more than Apache Bench and WRK. One of the things one of the tricks that Autocannon uses to do this is it doesn't use Node's HTTP module. It uses the TCP module directly and creates the HTTP strings itself. It also uses something called pipelining, which gives it the edge. Node supports pipelining out of the box. So if you're testing a Node server, you can really put your server under some pressure. The other trick with Autocannon is it uses something called the native HDR histogram module, and this allows us to record metrics at high accuracy because the overhead of recording those metrics is reduced to about 5 nanoseconds. So yeah, the next thing you should really check out if you've not heard of it before is Autocannon. Other things that it has is actually that WRK and Apache Bench don't necessarily have is automated benchmarking. Yes, you can script AB and WRK, but with Autocannon you can use JavaScript to create an automated workflow. This can be pretty useful because you might want to test multiple routes at once to see how they interact. And at a JavaScript level, this can make a difference, because if you have a function that's polymorphic, e.g. one that will accept different input types, and you only call that function with one input type, it will be fine. But as soon as you put another input type into that function, the function will de-optimize. If you have two separate routes that are using the same function in different ways, you can expose that de-optimization by testing multiple routes at once. And the scriptability aspect sort of helps you to do this. You could also use it for CI pipelines, things like that. One other thing is that Apache Bench and WRK, it's quite tricky to get them to run on Windows, whereas Autocannon, it's a Node module, so you just npm install the module and it's there. And this is why Autocannon is now used in Node Core. And then finally, there's Pinot. If you've heard of Pinot, it's a high-performance logger. Essentially, it's compatible with the Bunion interface. It's the fastest logger that we know about in the Node ecosystem. To give an example, and you can see these benchmarks on the Pinot README. If you take 10,000 log operations and you run them through Winston, it's going to take about 3.5 seconds. With Bunion, it's going to take about 2.5 seconds. With Pinot, it takes 250 milliseconds. And in extreme mode, which is a couple of trade-offs with that, you can get it down to 100 milliseconds for 10,000 operations. And this doesn't seem like a lot, but if you're looking at serving a high amount of requests, say 10,000 requests a second, and you're logging 10 requests, sorry, you're logging 10 messages each request. That's 100,000 requests. That's 100,000 log messages a second. So you really need to keep the overhead of logging down, and that's one of the reasons we created Pinot. It's called Pinot because Matteo is Italian, and there's a pine tree outside his house. So we basically, Pinot was sort of a case study for us to sort of apply a lot of what we've been learning to and the tools 0x and autocannon to something, to have an outlet to put this all into. And we were fortunate that we had the resources to do that as well. So there's a couple of lessons I just want to share with you that we figured out in the course of Pinot, and each of these slides actually links to a PR on Pinot that you can actually go and look more into. So the very first iteration of Pinot, we used a val. It's a trick, basically. If you can serialize the input to a function in some way, so if it's a number or a string, it's fine. If it's an object, you can JSON stringify, or an array, you can JSON stringify, and actually concatenate those together as a string. Pass that through a val or new function, and now you have a self-contained function that doesn't take any inputs. And it turns out that V8 is really good at optimizing that because it's not accessing any closure scope or anything. But I kind of had a chat with Matteo, and I said, look, even though this is fine to do in this particular case, because we're not handling any user input by doing this, we're essentially just pre-compiling a function. It will put people off from using the logger, and the whole reason we're building this is so that people can essentially have a lower overhead logger. So we try to with the deliverers, with the eval approach, we were getting 10,000 operations at 350 milliseconds. So it was still really good. But we basically refactored and we're only about 10 milliseconds off. And we were able to do that by instead creating a function that takes a limited amount of parameters instead of using the arguments object. So you could take, essentially, the function looks a little bit like, let me just write a bit of code. A little bit like, and I know that seems silly, but to be fair, if you want to log more than 11 things on one line, maybe just break it into two. But when we realized that we could do that and actually get similar performance to the eval trick, we started to sort of go in another direction and try to see how much more we could squeeze out of it. So the second thing, and this is the second pull request, was that we realized if you build strings, if you build JSON as a string manually, instead of passing an object into JSON stringify, you take the properties from that object and build the string yourself. You can get what we got was about a 25% performance increase. So JSON stringify is a serious bottleneck, and JSON parse, they're both serious bottlenecks. So if you can figure out a way to minimize the amount of stringifying you have to do, then you can get some pretty big wins and some pretty low-hanging fruit. Of course, you need to know certain things about the object, what properties it's going to have, and for the properties that you don't know about, you're going to have to stringify, or any objects that have properties you don't know about, you have to stringify those. But essentially, by building the string ourselves, we were able to get about a 25% performance increase. Another thing, again, that gave us a 25% speed increase was to stop using to ISO string. And we were able to do this for two reasons. The first one is by not using JSON stringify, any date objects that were on an object don't get passed through the toIso string method on the date object. Because under the hood, what JSON stringify does is it encounters a date object and it calls toIso string. But because we were building the string ourselves, we were like, well, actually, we don't have to call toIso string. We're going to use date now instead. So by using millisecond timestamps instead of ISO string timestamps, we got another 20 to 25% speed increase. And then we supply a transform, which you run as a separate process. So you pipe your output into that separate process that, if you want, will give you that ISO string back. Another thing was closure scope. This was about 10 to 20% increase. So when we were creating child loggers, a child logger is essentially a logger that spawns with some state from the parent. And to retain that state, we were using closure scope. By changing that to creating, well, initially we used a constructor, but now we just use object create. To basically, instead of using closure scope, we create an object and use the this context keyword instead of accessing closure scope. It gave us a 10 to 20% increase. Again, look at the PR21 for more details. And then finally, the accidental discovery. So there's a flag that you can set on Node called allow native syntax. And I was going, and there's these special methods that you can call with the % sign. So I found one, I think it's percent flatten string. And you can call this method when you have allow native syntax on. And I thought, hey, I'll just call this on the strings that we've assembled in Pinot. And it gave us a 60% performance increase. And so I started sort of deep diving on why that was and how I could achieve this without that native syntax. It turns out that this flatten string function calls at the C++ layer string flatten, and the number constructor, as well as a bunch of other things like the regex parser and different things, call string flatten. So I benchmarked the different ways of doing it, and the number constructor was essentially the fastest one. So if you take a string and you pass it into the number constructor and return the same string, what it does is it basically, it's like a defrag on the string. So when you've built a string out of lots of little pieces, instead of being like a char array at the C level, what it actually is like a tree-like structure with a lot of pointers. If you write that tree-like structure to a buffer, the buffer has to bounce all around the pointers. But if you flatten it first using their internal string flatten via the number constructor, it basically does like I say, like a defrag on the string, and then you pass it into when you pass it as a buffer into a write method, it writes about 60% faster. So there's a module called flat_str that I publish as 4 lines of code. It gets 30,000 downloads a month. But the reason, which is funny to me, but the reason I published it as a namespace module was because, like, if you just pass something randomly into number constructor, no one knows what's going on. So Pinot's been growing, and the ecosystem around it's been growing fairly well. We've got a Pinot.js org on GitHub, and we invite people if they want to build something for it. Like, for instance, Pinot Kafka is still on the to-do list. If they want to build something for it, just open an issue on the main Pinot repository and say, hey, I want to build this thing, and we'll help you to build it in a performant way. So you make a first pass, we'll give you some feedback, etc., etc., etc. And if you're happy with it and we're happy with it and you're happy to put it into the Pinot.js org, we'll invite you to the org and you can be like a lead maintainer of that piece of the Pinot ecosystem. So there's a bunch of different things that have kind of grown up out of this original kind of thing. Finally, very, very quickly, I'll talk about one other set of things that we did, and it's for a company that I can't talk about, for a project that I'm not allowed to speak about either. But essentially, what we did is we helped them profile the entire deployment, the whole lot of infrastructure. So if you're doing something like that and you go in sort of larger level kind of architecture profiling, what we did was we set up a benchmark machine within the AWS deployment. One tip: don't use AWS T2 instance for running benchmarks. We got given a T2 instance and then quite quickly realized, wait, what are we doing? T2 instances are burst instances. They depend on supply and demand as to how many resources you get with them. So they're obviously terrible to use as a benchmarking machine because your results are going to be different every time. The ideal machine for benchmarking is an M3 large. And whilst there's a big temptation to say, okay, we need to set up a big cluster of machines to like benchmark our app, you really don't need to do that in the first place. Definitely not in the first place. You can get a really long way by tweaking the settings on an M3 large and using autocannon, because autocannon is really it really is like a fire hose. So we would essentially hit the server with autocannon from an M3 large instance that had the kernel settings tweaked, which I'll show you in a second, and then we check the load balancer, the machine and container setups, cloud health checks, measure CPU, memory, disk usage, check the caching layers, all that stuff. If all of that stuff checked out, then we check the actual node process. So it's a really cool, fun thing to do, going all the way down like that. We also created, as an aside, we started working on something called Anger, which is for WebSocket testing. And that's a very interesting thing to profile, because you get into fan-out testing and do we load test or do we emulate users and that kind of stuff. So the thing that I was saying about with autocannon, where it's scriptable, essentially as a part of this engagement, where we left it out, we kind of seeded this sort of automated reporting idea with them, and they ended up just having a whole CI pipeline based on scripting autocannon to benchmark their deployment. Okay, so we're at the end. Sorry, a few minutes over, but let me just see if there's any questions. I click here. Not a question, but a great statement. Pinot in Greek means I drink. Well, awesome. It's all good. There's even a module called, there's two modules that are based on that whole concept accidentally. There's Pinot Noir, which is for log reduction, which is a play on the words with, Pinot Noir and Pinot Noir. It basically does high performance reduction. And then there's Pinot Colada, which is by a dev called Ira. She's independent from us, but it's a really beautiful prettifier for Pinot, you basically pipe the JSON into it. So we have an example here, Node pipe the JSON in, and it uses Unicode and different things to codify it. That's being used pretty actively in Mary, which is a high-speed, great little HTTP framework. Another thing I should mention that came out of this was Fastify, which is something that Matteo and Thomas Delvador are working on, which is a very high-speed web framework with support for middleware, and it'll even consume Express and Restify middleware as well, but do it faster. Yeah, cool. So one other thing I want to say about was everything I've talked about and the sort of different tips I've given, I've stayed quite light on them on purpose, because when Node 8 comes out at the end of this month, actually James Snell will probably talk about that this afternoon as well. When it comes out about, I think, April 25th, it's going to come with the V8 version that has turbofan and ignition support enabled by default. You might want to look those things up if you don't already know about them, but essentially it's changing the whole performance characteristics of JavaScript on for the V8 engine. So that's for Node, Android, Opera, and Chrome. The performance characteristics are going to change. Largely, it's a good thing, because they're optimizing for cases that make more sense, rather than and optimizing for where expectations are. So, for instance, one expectation would be that native methods like map and reduce on the array prototype would be fast. It turns out you can do it faster. For instance, Lodash is way faster. So they're trying to do things where basically your initial instinct on how it should work actually is correct, becomes correct. So I imagine some of these things will definitely still apply. Like, I don't see them getting date to ISO string faster than date now. Oh, a little side note on that. The way that Node Core does it is very clever. They have to create a date timestamp for every HTTP request, because it's always on the HTTP header. So what they do in Node Core, and I've written a module called fast-date that does this as well. Because a timestamp is every second, they basically cache the timestamp for a second, or for whatever's remaining of that second. So say it took 100 milliseconds to generate it, they'll cache it for 900 milliseconds. This does lead to very slightly skew with timing sometimes, but not in a serious way. And actually, that'll get you close to date now performance. Show you here. But some of the things that are going to be, so this is fast date benchmarks here. If you use date normally, 215 milliseconds. If you use fast date, it's pretty much the same as the speed of date now, but you get ISO timestamp. We're looking at integrating that into Pinot as a plugin, because now everyone expects Pinot logs to have timestamps. Millisecond timestamps. So the thing with turbofan and ignition is that things like optimization killers are going to be a thing of the past. So, like, using try-catch, for instance, was typically a no-no, because it would cause the function to not be inlineable and to not be optimizable, because Crankshaft, which is the previous engine, wasn't able to deal with it. Now that's not going to be a problem. You can use try-catch and it's not going to slow your code down, which is pretty amazing, actually. And the other commonly known killer was leaking the arguments object. So if you return the arguments object from a function, even currently right now, you're gonna cause a bottleneck if that function is used heavily, because it's impossible to optimize the function. I believe turbofan solves that too. So yeah, get onto Node 8. I think is a big takeaway here when it comes out, because you'll probably find your code's going to run faster. Okay, so I'll finish off with a prophecy. the prophecy essentially is that we're going to get to a point where there's a lot more awareness about performance, but a lot less to know because of these changes that are coming with Turbofan, and that we're all going to live in harmony and peace forever. All right, thanks very much, everyone.